So ADBA, Asynchronous Database Access API. This presentation was put together by our architect. He is the lead of the API, and myself. Okay, so this is our disclaimer, or legal obligation. I'm not going to read it for you. So I'll do a quick intro, why we're doing this, what is the execution model, etc., etc. And then the gist of the presentation will be going through the API, through code samples. So it will be a lot of code. Okay, so we are proposing this as a new Java standard. When I say we, it's not an Oracle proprietary thing. We want it to become a Java standard. So we're working with the JDBC expert group and the Java community to make this a new standard. Right. So we hope it's going to make into some next Java release. I do not put a number on that. So we hope for 12 months. And so why are we doing this? First of all, throughput. I think the JDBC is synchronous and blocking, and that reduces your throughput. So if you have a non-blocking API where you can fire operation and forget, or maybe come back and do some other operation in the meantime, it will increase your throughput. So throughput is the first motivation. Now, having discussed with the Java Streams proponents, we talked to companies like Lightband and Pivotal, and those guys are really strong, religious proponents of reactive streams. So, following that, we injected support for reactive streams in the API at few places. So this is not a full-fledged reactive stream database access. We're not following the reactive manifesto, etc., etc. But we have enough support for reactive streams in the API. Anyway, so you will hear me say this all the time. The primary characteristic of this API is user thread never block. So user thread will prepare and submit an operation and return. The implementation or the driver will execute the operation asynchronously. Okay. So it's an alternate API. It is not a replacement for JDBC. It is not an extension to JDBC. It's a completely separate API. So as I say, we target high throughput application. The other thing is it's built exclusively on the JavaSIG library. We have no dependency, zero dependency on third-party library. And that was a sort of the point of contention or disagreement with the proponent of the reactive streams people, because if you want to have a full-fledged reactive stream driver, you have to depend on some third-party reactive stream library. So that will not make it a standard. But we want to support those full-fledged reactive stream API. We want to support them. They can build on top of ADBA. And one is already doing that. So design choices. No reference to JavaSIG. JavaSIG is JDBC, so we have no reference to JavaSIG. Rigorous use of type. Compared to JDBC, in JDBC you have statement dot execute with a string as a parameter. If you take prepare statement and you do the same thing, prepare statement dot execute with a string parameter, it will compile, but it will throw an exception at runtime. So it's not completely rigorous because prepare statement is an extension of statement. Anyway, so using the build pattern, Fluent API, objects are immutable after initialization. One way to do things is, okay, we don't try to come up with different ways to achieve the same thing. No SQL processing by the driver, I will talk about this later. and no callback help. Everybody is aware of that. So people say, but there already are Java, async APIs and JavaScript async APIs. So people were recommended to build this on top of Java streams. But Java streams is inherently blocking. Our goal is no blocking at all, in any case. Anyway, so ADBA, we do use Java util concurrent flow in few places, and I will describe those places. Now, there is this reactive relational database connectivity. This is an initiative by somebody at Pivotal, and they want this to be a pure reactive stream database access API. It's a new thing, it's on GitHub, so you can look at the API on GitHub. They adhere to the reactive manifesto, non-blocking back pressure, but they have a dependency on the reactor library. Okay. Anyway, they also have a wrapper on top of ADBA. We went there, we presented ADBA to them, at the San Francisco Java User Group. So they're aware of ADBA, we have been exchanging on the mailing list, etc., etc. So they do have a wrapper on top of ADBA. But our goal is to support any pure reactive stream API on top of ADBA. Okay, so now I'm going to go into codes so that you can see exactly what the API looks like. First, we want to do an insert statement. So, contrary to JDBC, where you have statement, prepare statement, callable statements, in this API, the kind of operation you will submit or you will use depend on the return of the SQL statement that you are executing. So an insert returns a count. That's why we have a row count operation. And you will see in the next example that a query returns rows, series of rows. Then we have row operation. Okay, so and so on. Okay, so here we have a session as a parameter, a session, and then an item, which is a podium. And then we have a row count operation to execute the insert statement. So we set the value for ID, for name, and insert, and then submit. That's all the user code, the user Java code, that's what he has to do. Declare the operation you want to perform, set the parameter. You might need to provide some results secondly, but I will talk about this later. So the API is heavily based on completable completion stage / completable feature, which is the class. So I hope everybody here is familiar with completion stage or completable feature, right? Okay. So you can look at it. So it is one of the async mechanisms in JavaSIG. It starts with JavaSIG 8. It allows task composition, lambda expression, flow programming, etc. So we do use this heavily, and you will see in our examples. Okay, so the execution model is everything is an operation. I mean, everything which talks to the database is an operation. So SQL statements, database operations, parameter assignments, result handling, all those are operations. Now, the user thread, prepare and submit operation. The implementation, in other words, the driver, execute those operations asynchronously using some other thread. So the user thread is not waiting or blocked for the execution. The user thread just submit and return. Okay. So we will see more examples and we will start to understand better. This is to get a data source, so you need to get the data source from the factory. So here we have the Oracle database.aws ADBA as a factory. If we have an implementation of ADBA for Postgres or MySQL or some other RDBMS, they will have their own factory, data source factory. So you take the builder, set the URL, the username, the password, and build the data source. Okay. Now, from the data source, we want to get a session. A session is like a connection, but it's not exactly a connection because a connection is already established with the database. It's already open to socket, it's already attached to the database. Here, a session is something that will be attached later when the implementation executes. But when you are preparing the operation, nothing is happening. There is no attachment on the network. So it's a sort of to become a connection, but it's not yet a connection. So you need to get a session from the data source, and you can see that this is the implementation, this is the code of the API. That this is not the user code. The user code just use get session. It's a convenience method. You don't need to do the builder build attach. But we're just explaining how things work. So get session does that. So attach will submit a group of operation or an operation group. I will explain what is that later. And then it will submit the session as an operation itself. So that's why you see this.submit, the first this.submit submits the operation group. And this attach operation submit attaches the session to the data source. Whatever. Get ID for answer. So here we have a data source as a parameter. We're going to recoup a list of integers in the result. So we're using a try with resource block. We get a session. We're going to get the session from the data source. So data source get session. Then, by the way, we use tag witness. In some of the examples, you will see tag witness. So this is a combination of the way ADBA has been implemented. So we have to specify that. Our expectation is that developers, human, will not use code ADBA directly. I don't know how many people here code JDBC directly. Do you code JDBC directly, or you use JDBC through some framework which generates JDBC for you? Both. Both, you said? Okay, yeah, both. So maybe an ADBA, maybe it's going to be both, or maybe we will work with some framework providers and they will generate ADBA for you. But when you're coding, you will need to specify some tag witness. Okay, so row operation, because it is a query is a row operation because it returns rows. So the query is select ID, name, answer from tab where answer equals something, some value. So we need to set the value for the bind variable target. So that has been set. And every time we specify the type, the data type, all the time we have to specify that. Okay, now you need to provision how you want to process the rows, the result handling. And the way you process rows in ADBA is you collect them. So we have a collect function. It is a convenience method, part of the API, but it uses Java collectors, right? So we have a supplier, then we have an accumulator, which is an accumulation function. So we take the list and we take each row and we add to the list the value of the integer at the column ID. So in a row has multiple columns. One of the columns is ID. So at the ID, we get the value of the integer and we stuff it into the list. So the list will return a list of integers. So the user thread uses this try with resource block, specify the operation, specify how to handle the result, submit and return. That's what the user Java code, that's what it does. So it does not wait for the operation to complete. Okay.
Can I interpret the question?
Yes.
Is it possible to pass in an accumulator as a parameter, or?
I have not looked into that, but I guess yeah, I guess, yes.
I mean, just to create it lambda dynamically, right? But you could create it externally, and
you could create externally and give it to, right? Okay, yeah, definitely.
Because probably just by consumer or something, right? In your API of collect.
Right.
The accumulator is by consumer. The accumulator is by consumer.
Right. Okay, so that's a trivial select. I'm going to have more complex operation. I'm just showing you the close operation here, how it is implemented. If you're using a try with resource block, as we've seen in the previous slide, you don't need to explicitly close the session. When the blocks is complete, the session is closed. But we're just showing you the implementation of the close operation. As you can see here, even the close operation never blocks. Vendor SQL support. The choice is to not deal with vendor-specific SQL, because, as you can see at the bottom of the slide, different vendors use different parameter markers. So look at DB2, they use column, MySQL use question mark, Oracle use column, Postgres use dollar annotation, SQL Server, and so on. So it adds complexity to the implementation, because you have to deal with some abstract SQL language, because even though they say SQL is a standard, it varies depending on the vendor, right? We know that. So the choice is we just pass the statement to the database. And the other reasoning is if you have an ADB implementation for a specific database, for example, Oracle, that implementation will not have to deal with the MySQL or Postgres parameter markers. It will just deal with the Oracle parameter markers. Anyway, we do not, the driver, there is no provision to process vendor-specific SQL. Okay, more complex example. Here we have we're going to return a list of items. We're going to return a completion stage, which will return a list of integer. Okay, so we have a data source as a parameter, and oh, sorry. Okay, here we are. We have the data source as a parameter and an integer. So we have the try with resource block, get session, and that should return a list of items. Okay, and this is a type witness. So here again we take a row operation because it is a query, it is a select, so we need to set the value for target. We set the value to 42, and then we specify how we're going to process the result. So we invoke the collect, and we give him, it's going to use collector to mapping means apply this function to each row. So the function means create a new item, which is a POJO, by collecting the value at the column ID, which is an integer, at the column name, which is a string, at the column answer, which is an integer. So we're going to create an item with those three for each row. Okay, and when you're done, we invoke another collector which is going to build a list out of those items. So we're going to return a list of integer, and so you submit, and then we get a completion stage, so that it's going to return a completion stage for any code which invokes this function.
You said in there like target 42, right?
Yes.
You could set up target to answer, right? Because probably that's what it meant originally. You pass in, instead of hard coding 42, you meant.
Yeah, we could have used the answer, which is
Right, because otherwise it's not.
which is given here.
Right,
Yeah, we
right.
could have done that. Yeah.
5 seconds.
Yeah, we could have done that. I mean, those examples are not rigorously precise. They're trying to illustrate some concept of the API. Well, point taken. I'll report back. Okay, transaction. The problem with transaction is there are different timelines. So there is the Java code timeline, the database timeline. So what I'm trying to say here is when you submit that operation, you have no control over the execution. So you cannot go back and change, the outcome. For example, you want to roll back instead of commit, or you want to commit instead of roll back. So you need to provision something which helps you make the determination whether you need to commit or roll back. So that's why we come up with this flag, a mutable object called a transaction completion, transaction completion object. This flag will be set depending on the outcome of the execution of the different statements that made up the transaction. So this transaction is made of two operations. One is the select, and the other is on the next slide, which is an update. Okay, so let me go back. So this is a select. We do a select, and we're gonna recoup in ID promise an integer following the execution of this query. So we set the value for this placeholder, and then we collect the result. So collecting on them, so we're gonna map for each row. We will recoup the value at the column empno. Okay, and then we're gonna give it to this collector, which is gonna make a list out of that, and then we're gonna recoup the first value of the result set. So if there is an error, we're gonna set a value for the flag, the transaction completion object is gonna set rollback only if there is an error during that execution. Okay, so you submit, you get a completion stage. We come here, this is a row count operation because it's an update. So we set the value for the placeholder, the set value for this one to 1, and set to the second parameter will have the value of ID promise. So ID promise is a completion stage. You see here? Which means this value will be set only when the query is completed. So the update will not happen before the query. Okay, so apply this as a count, the get count, apply the get count function. And if it's not 1, if it's different from 1, then there is a problem. So we're going to set rollback only and throw an exception. And then otherwise we return get count. Okay, so if there is an error, we set rollback only here as well. So you submit the operation. And here, this is something you will not skip. We need to cache errors. Okay. And depending on that, depending on the value of trans, depending on what the outcome during the query or during the update, we're going to set commit, maybe rollback, depending on the value in trans. So if trans was set to rollback only at one point during the execution of those operations, it's going to be rollback. But if it has never been set to rollback, it's going to be commit. Is it okay? Operation group. operation groups are a group of operations. And to make you grasp what this means, for example, a session, which is a to-be connection, a session is an operation group because it has members. The members are the operations that you submit using the session. Okay, a group of operations can have its own completion stage. The members are submitted as a unit, so you can say, I want to submit all the operations belonging to that group. You can execute them sequentially or in parallel. For example, when you have a session and you're running different operations, those are performed sequentially. So a session at the bottom of the slide is an operation group which is sequential, which is dependent and unconditional. Okay, so what does it mean? Conditional or unconditional, it depends on a Boolean. You can set a Boolean to say this will be performed depending on such and such condition. Okay. Now, dependent or independent, that's a choice. Dependent means if there is an error, the rest of the operations that make up the group, the operation group, will be skipped, will not be executed. Because it's a dependent operation group. But if it is independent, we can skip even if one operation fails. So, for example, you are cutting checks, you're printing checks to pay your employees. There is an error on one of them. You don't want to skip the rest. You still want to print the rest of the checks. So, gives you an idea of operation group. An example to grasp that, let's do a parallel update. So, this is a parallel update. We're going to have a list of items and the data source as a parameter. So we have a query and an update. This is the query. This is the update. Try with resource block, get a session, declare that this is an operation group. So the session operation group, we specify this is independent, which means if one fails, we continue. It is parallel, so operations can be executed in parallel. So it's not sequential, we don't wait. So you submit the group. You submit the group, and then you have to submit operations, the members, individually. So first of all, you need to submit the operation group, and then you submit members. So in the for loop, we're going to submit the members of the operation, the members of the operation group. So here we have a completion stage, ID promise, list of integer, row operation to execute the query. It's the example we have used before that we are reusing here. So set the value for answer here and specify how this should be collected, should be processed. So we have a collector of, it's going to new array list, it's going to have an accumulator, add the row, add the column ID. So this is an integer, we're going to stuff them into the list, and then return the list, submit, get a completion stage, then apply, recoup the first element of the list. When it's been completed, recoup the first element of the list. Okay, so the next is we want to do a row count operation, which is the update. We set the value of ID to ID promise. Remember, ID promise is a completion stage. So this operation will not complete until the query has been completed and ID promise has been set, a value. Then we set the value for them, we submit, get the completion stage. If something happens, it's going to complete exceptionally. Or will be through an exception. Anyway, so that gives you an idea of a parallel update, which are independent. The last part of the presentation is about where do we support reactive streams. Non-blocking back pressure. That's what reactive streams That's what they want. They want non-blocking back pressure. Okay, so in our implementation, as I said, we don't have any dependency on third-party library, but we do support the Flow API, and that's the only thing that we have to support reactive streams. So for those non-familiar, the Flow API has two interfaces, the publisher interface and the subscriber interface. So if you are a Java core, what we ask people to do is to implement the function part of the interface. So you're going to implement onSubscribe, onNext, onError, and onComplete. Those are the four functions that the Java user code has to implement. And when you provision a subscription object, it will be used to control the flow between the publisher and the subscriber. So we're going to use this to support a row operation. We call it row publisher, but it's how to consume rows or results of a query in a non-blocking back pressure support manner. Okay, so we have a data source, we have a query, select emp node, ename from emp. This is a completable feature, it's a list of string. Okay, so we create a new completable feature. We now do the implementation of the subscriber interface. So we create an object, a subscription object, which will be used between the subscriber and the publisher. Okay, so here we have a new release. The demand is set to 0. Unsubscribe. This is the first method which is called before things start. So this will have a subscription object as a parameter, and this is important. We invoke request on the subscription object with the value 10, which means we are telling the publisher, I can take 10. Don't give me more than I can consume. So give me 10. And you start by giving me 10. Okay, then on next, which is the most important function because that's the one that's called several times. Unsubscribe is only called once. On next is called all the time. So on next, we're gonna add the name that we will recoup, the string that we will recoup at the column ename. So we're gonna add this to the list of names. And if the demand is lower than 1, we're gonna request 10 more. This is how we can coordinate between the subscriber and the publisher so that the flow is, there is no blocking back pressure. On error, so that there is an error, you're going to complete exceptionally. If it's complete, incomplete, well, you just complete, so you return the names. Okay, so that's one implement, and this is the code itself, the application code itself, because what I showed you before was the implementation of the interface. So here we have a try with resource block, get it session, and the row publisher operation will execute the SQL operation. So we invoke subscribe, subscriber, submit, get completion state. Okay? It gives you an idea of how we support non-blocking back pressure when you are recuperating the results of a query. So that's one place where we support reactive streams. There are two other places where we support reactive streams. One is submission rate, to control the rate of submission when you're submitting operations. The implementation of the driver needs to tell you if it can get more. Otherwise, if you keep submitting operation and the implementation cannot sustain or cannot process, then you might get to a situation. So this is the second place where we will be supporting reactive streams, and you can see this in this example. So here we get a session, and unsubscribe. This is the implementation of unsubscribe. We say this is an operation group. It's independent. and this is how we're gonna collect the result, submit the group, and request hook. This is important. This request hook, which is a function of the session object, will invoke subscription request by telling the subscriber, I can receive more operation. Okay. On next, so we just implement the insert. These are the operation where you will do an insert, row count operation, set record, apply, submit, etc. So this is your usual sort of operation. You are submitting operation, but we do have a provision to control the background.
Is the byte item coming in?
What is the question? Byte item?
What's the input into on next?
The item here, I think it was declared somewhere. I don't see it.
Parameter of subscribe.
First already.
All the way up top.
It's on the implements.
Yeah,
Upper
the
right.
implement.
Here. Okay.
Yeah, but this is basically asking for permission to submit more operations. So
It's the implementation telling the application that it can send more.
So in that context, I don't understand what's the input there. What's the byte array? What does it contain?
Probably if you go like a couple of screens back when you were
Yeah.
talking about subscriber.
On the row publisher.
Right.
On the row publisher here,
And then it's a different example.
but this is a different
No,
example.
you see that you have subscriber parameterized by result row column.
This one is consuming.
This is the consuming rows.
Right?
The other is,
Now if you move to the next screen, you see on next gets the column which is what subscriber parameterized with. So on next, and if you go back one screen,
okay,
on next and on next and there was another.
so one thing I can say to my defense is those examples are not rigorously scientific, but it's to illustrate the concept. So I probably need to talk to the architect and we need to fix that. I don't know why we have this array. Subscriber.
It means that the publisher is producing these byte array items, and they seem to be tied to the operation. So somehow maybe they were provided. It's just a little strange to reconcile with like the upstream giving you permission to make more operations. There's something missing from that.
Something is missing in the example, yes, definitely. Okay,
Well, it looks like subscriber expects. Well, on next there's a callback from the publisher, right? And it gives.
So on that will mean we can submit more insert. We're submitting an insert, an operation, a row count operation. Here we declare that we are submitting a group of operation, and yeah, I don't see the.
This is a subscriber for the byte array, so the publisher, like was almost pointed out, is publishing byte arrays of some sort.
Right.
So
So
is that actually is that in the unsubscribe in just the previous slide? The first thing there, session operation group.
Operation group, yeah.
Uh,
This is a declaration, and this is an
what is it
operation
collecting
group.
actually?
So long.
look back at the API of subscriber. What the methods of subscriber are.
Okay, I can go back to this row count operation.
Exactly.
So on the subscriber, this is the subscriber.
One more back.
One more back. Okay. So this is just an illustration of the API.
Right, so on next is data, right? So
Yes.
parameter data is what the templatized parameter of subscriber.
Okay. Well, you can see that I did not write those examples. Okay, anyway, so this is the second place where we are supporting reactive streams. And the last is session creation, controlling session creation. Let's say you have a database and you don't know how many sessions you can create or how many sessions they can support. So we need a mechanism to control the session creation rate. And here again, we are using request hook so that the implementation can tell the Java user code, you know, if it can sustain more session creation or not. Okay. So this is sort of okay. On next, we just create a session, insert an item. So this is the main method. And that's it. So those are the three places where we support reactive streams in the API.
If you go back again to one screen,
Okay.
you see a subscription request. This is where publisher solicits request from the subscription, right? Request hooking. Publisher asks subscriber, give me another request, right?
Yeah. So the request hook it will invoke subscription request.
Right. So subscriber sends request to publisher, and publisher, in our case, returns items, right? This is what subscriber is parameterized. So on next, takes parameter item, which is what publisher published back to subscriber.
Thank you for correcting the example. I need to report back. Okay, to wrap up, and I think I did it in a timely manner. Every time we present this API, the complaint is, when will this be available? When can I play with it? You know, we need to. I can see the API, I can read, but if I can write the code, I can compile, for example, write the code which compiles and which does not have those errors that you have seen. So we came up with a proof of concept, which is a blocking proof of concept because we are using vanilla JDBC. So we take the API and we implement the API, but since we don't have the asynchronous driver yet, we are using JDBC. So what does it mean is you will not have the async behavior. Your code will compile, it will execute, but it won't be async. It's just ways for people to fill the API, not the behavior at runtime and the async behavior. Anyway, so we've done that, and it's on GitHub, and people have branched. Somebody has done we call it AOJ, stand for ADBA over JDBC, and some folks have done an implementation for Postgres. I mean, we know at least 2 people who have branched out. So here is where you get all the information about the API itself. So the API is here. You can download the classes. It has about 29 classes. And this is the mailing list where this is being discussed. This is the mailing list of the JDBC expert group. So we discuss JDBC, we discuss ADBA, everything is discussed on this mailing list. So my request is, can you please go on this mailing list, read what people have been saying, and add your own comment or your own. For example, when we engage with Lightband and people thought it was because they made comment on the mailing list, and we monitor the mailing list every day. So we know if somebody has any comment. And here's where you can get the AOJ, the ADBA over JDBC, and this runs. It has examples there, so you can get it from our GitHub page. We just do not receive contribution because of the legal issue. You know how it works, right? In every company, you go to legal, they say, no, you can't do that. So to avoid that, we pretend that this is a code sample. which it is. It's a code sample, so you can grab it, you can play with it, and we hope it's going to get out. If it does not become a standard, at minimum we will have a JSR, and people can download the implementation and use it. So that's where we are. I think that's what I have. Yes.
You mentioned Java 12 and a JSR, but isn't the window of opportunity closing?
Yes, that's why at the beginning, I didn't want to mention Java 12, because we don't know when. I mean, it all depends on the community, because we want to freeze the API at some point, and each vendor can go and do the implementation. So, yes.
Is Oracle working on a driver?
Yes. But the thing is, we are careful because as the API is not frozen, we cannot pretend that it's an implementation. But at some point, because the JDBC at Oracle is built on the database release train, so if they're gonna close the release, we probably do something and say, oh, this is just a better version, or throw away, anyway. So yeah, we're actively looking into that.
But I mean, if it can be Java 12, you should know that by now. Isn't that the case? If you don't know that today, that means it's not complete.
Well, we have it till end of December, right?
Well, which is how many weeks away?
They actually closed Java 12.
3 weeks.
Yes.
Holidays.
Yes, I mean, we're doing the best we can.
And so, actually, one of the reasons why I'm asking is because, and you mentioned the API possibly changing. What is the possibility that you might change your mind about Reactive Stream support to be more available? And I'll add one side note to that, so I don't want to start a whole big discussion, but one of the big differences between a Reactive Streams API and, say, completion stage is not just the back pressure, but also the deferred control in execution. And it's usually in asynchronous applications, if you're using a reactive library, it's very important to kind of construct the whole chain, and nothing actually happens, just like with the Stream API, Java Stream API, until somebody subscribes at the very end of that chain. So you make a big pipeline, and then at the end connect everything, and then you subscribe, and that triggers everything upstream. Whereas with something that returns completion stage, you're technically triggering that immediately, and you're going to get the result at some point later, but it's being triggered.
Correct.
So that's why generally, mixing and matching between completion stage and then reactive stream-based querying, it's a little bit of a mismatch.
Right. So I've been.
And also, sorry, one more.
Yeah.
And that actually works with the back pressure, because if you're doing something and then you're doing a nested operation, and even if you're just fetching one thing, that should still be dependent on somebody saying, yes, go fetch it, as opposed to like going off and fetching it. It's kind of like a little bit like back pressure as well, but it's the deferred nature of declaring composing logic that shouldn't execute just yet.
So, can I ask you a favor? To go on the mailing list and post that.
I work for Pivotal. We've been on the mailing list.
Oh, okay.
I work
Okay.
with the people you met this afternoon.
Right, and the point of contention, and I've been saying in many presentations, and the architect who's the leader of the API, his main argument is we cannot have a standard which has a dependency on third-party library.
Yeah, and my take on that is that with something like ADBA, it's important to provide a foundation which works well with
That
libraries.
can build some
Especially,
stuff, right?
as you stated, that the expectation is that many times people will use it through some sort of an outer wrapper or layer. That outer layer, like R2DBC, can only be as good as what the foundation provides.
Is,
So if
right?
there are things that it does not provide, then it's difficult to make that layer behave as well.
Right, so
at least we have an SPI-friendly layer that makes it possible, but then the completion stage, if you want to consume it directly without.
So I will report back to the architect and the team, and he will talk to those people.
What does SPI stand for?
Sorry. So the
Service
API
provider,
is something that's more used by
Got it.
third-party libraries. something that's not necessarily for consumption directly by the application.
Right,
but
it's not API, it's SPI.
Yeah.
Service provider interface.
Is there a jet attached to any of that?
A jet?
Jet, J-E-P?
Oh, no, not yet. Yeah, that's what we say. If we cannot make this into a thing, we could probably start a jet or a JSR.
Because I'd be surprised if anything got into Java 12 without a jet attached. That's the whole.
Yes, I think we should remove the Java 12 and say future version of Java.
which is fine. I know 12 is probably ambitious for anything like this, but I was just curious because the JEP is the now kind of official way to standardize things inside the JDBC.
Right. Yeah. So we're struggling because the people who are responsible for JavaSIG are more busy with the fibers and Loom project than ADP. So,
well, it'd be interesting to defer, ironically, this sort of work until something like fibers came along.
yes, that's a debate. And okay, so what we're doing right now is to fiberize our JDBC
Yeah,
driver. We're doing that in parallel to this. So, anyway.
There's been some discussion to maybe not release it as part of the JDK, but make it available outside of the JDK. Is that still under consideration?
I think so, but I'm not really part of the JavaSIG organization. I'm part of the database organization. We do all the products, all the database products, and all the Java products for the database. Okay, one last, then I'll turn to. We're gonna see some fun stuff with the drone.
Take your time, please.
Okay, thank you very much.